In this video, I'm going to discuss least common denominators. So when we get to adding and subtracting fractions that have different denominators, for example, 2 over 5 plus 1 over 4, we're going to want to convert both fractions to different equivalent fractions such that the new equivalent fractions both have the same denominator. All right? And to do that, you have to find something to multiply the top and bottom of each fraction by. You multiply the top and bottom by the same number. And the question is, what do we have to convert the denominators to? So that's where the idea of finding the least common denominator comes in. Now, the background for this topic is prime numbers, prime factorizations, and least common multiples. You may want to review those videos if any of those topics are rusty. Okay? What we want to do to find the least common denominator, in other words, the least common multiple of 5 and 4 in this case, is first we find the prime factorization of each denominator. Okay? And then we ask ourselves, what is the new prime factorization that includes both of those prime factorizations? So 5 times 2 squared would include both of those, and that is equal to 20. So indeed, you can see that 5 and 4 both divide into 20. Furthermore, there is no number smaller than 20 in which both 5 and 4 divide into. Okay? So let's keep doing some examples. What if we wanted to do 1/3 minus 1/2? So again, we have to convert both fractions to equivalent fractions such that they both have the same denominator. And so let's analyze the prime factorization of each. And this one is funny because the prime factorizations are just the numbers themselves. So the prime factorization that includes both is the product, so 6. Okay? And so all of these will be the same. The punchline here is that finding the least common denominator is nothing more than what you already know is finding the least common multiple. Okay? It's an application of finding the least common multiple. It's an application to denominators specifically. Okay? So let's close this video by doing one a little bit more involved example. And I'd like you to try to pause the video and find the least common denominator for these two denominators. $14 and $20. All right, so go now. Try to do that one. All right, so I will work it out now. So 14 is equal to 2 times 7. That's the least common, or excuse me, that's the prime factorization of 14. 20 is 4 times 5, so 2 squared times 5. And then the new prime factorization that includes both of those is 2 squared times 5 times 7. Okay? And so this is equal to 4 times 35, 2 times 70, so 140. And indeed, you can investigate further if you like, but you will see that 140 is the smallest number that 14 and 20 both divide evenly into. Okay? Let me make one more comment about denominators that you convert to. Now, you can always get a usable denominator by simply multiplying. Okay, so for example, if you multiply 14 by 20, you would get 280. So you could simply do that. multiply them together, and that's a common denominator, but it's not the least common denominator. Okay, if you did that, you might have to work with bigger numbers, and it might be a little bit more effort, but that would give you a correct answer that you may then have to reduce. So just keep that in mind. But if you could find the least common denominator, that one will be the least amount of work.